So graphing functions part 1, it's easier to graph a function if it is written in y equals form. Because when we graph, we substitute numbers, we pick numbers for x and put them into the problem. So it's easier to graph a function if it's written in y equals form. Can you do it if it's not? I mean, yeah, we can figure it out. It's going to be a lot more work. And let's face it, nobody wants to do more work. So what we're going to do, today's whole lesson is about isolating the y variable. And what does isolate mean? What does it mean to isolate something? Damaris, what does it mean? Yeah. Get it alone. Make it by itself. How do you isolate the variable? Inverse operations. You're going to perform inverse operations are done to the constant, ends with a T. Inverse operations are done to the constant, and then inverse operations are done to the coefficient. As we'll make that step 1 and step 2. Inverse operations are done to the constant. Inverse operations are done to the coefficient. And then we simplify. We're going to isolate the y variable. How do you isolate the y variable? You do inverse operations to the constant, which are usually plus or minus. And then you do inverse operations to the coefficient, which are times or divide. And then you simplify the equation. All right, let's start easy. Are you ready? Yes, you are. Three x plus y equals 5. Here's what I do. As we're learning at the very beginning, I'm going to highlight my y because that's what I want isolated. I want that to be all by itself. And is it all by itself right now? It has no coefficient. But is it on this all by itself on the left side or on this side of the problem? No, it's not. If I pretend that that x variable isn't there, what if it just said 3 plus y? How would you get rid of that 3? So we're going to do the same thing, but subtract 3x. Because if I take this and I pick it up and I move it to the other side, I have to use inverse operations. So my 3x's cancel out. On the left side, I'm left with y equals. Can you do 5 minus 3x? No, they're not like terms. There are two ways to write it. You could write it as 5 minus 3x, and that's an okay answer. But ladies and gentlemen, it's not the best answer. The best answer is to always put your variable first. So I'm going to write negative 3x. And what's my value of 5? Positive 5. And I'm done. That's now ready to be graphed. I couldn't graph this up here, 3x plus y equals 5. I can graph y equals negative 3x plus 5. We've been writing earlier this week formulas that look like this. Let's try a little bit more difficult. Let's do 4y minus 12x equals 7. No, I don't want a 7. I want it to be something that works. 4. Sorry. So again, I'm going to take my highlighter because we're just learning how to do this, and I'm going to highlight the y. If I pretend that x doesn't exist, if the problem was just 4y minus 12, what would you do first? What would I do? Add 12. So I'm going to add 12, but it just happens to be 12x. Cross it out. On the left side, I'm left with 4y equals, can you do 4 plus 12x? What's the best way to write it? Dylan? 12x plus 4. Is y by itself yet? No. Not yet. I need to divide by 4, correct? Yeah. And over here, I'm going to divide everything by 4. So my 4's cancel out. I'm left with y equals, what's 12 divided by 4? 3x, right? And what's 4 divided by 4? 1. Is that my final answer? What did I forget? A plus sign because it was positive 1. Let's try this one. 4x minus 3y equals negative 9. I'm going to again highlight my y because I'm just learning how to do this. That's the one I want to leave behind. So if there was no x variable, if it was 4 minus 3y equals negative 9, which one would you get rid of first?
4.
The 4. It's called the constant, right? It's the number without the variable. To get rid of 4, I would subtract 4, so I'm subtracting 4x. Subtracting 4x. What's left over on the left side? Negative 3y equals, Dylan? Perfect. Negative 4x minus 9. Always put your variable first. My variable is negative 4, and then I have a negative 9, so it's negative 4x minus 9. Now I'm going to do what? What's my inverse operation now? Division. Divide by negative 3. Divide by negative 3. My negative 3's cancel out. Y equals. Here's the trick, ladies and gentlemen. Negative 4 divided by negative 3 is positive, right? Two negatives make a positive. And it's a decimal. Is that right? Yeah. I don't want decimals. I'm going to leave it as a fraction. I don't want improper fractions. I don't want mixed numbers. I do want improper fractions. You can leave it 4/3. If it doesn't work, leave it as the fraction. Maybe simplify, if it's 12/9, both can be divided by 3, but leave it as an improper fraction. It's got the variable x with it. Can you do negative 9 divided by negative 3? What is that? 3. Is that my answer? Plus sign because it was positive. And there's my equation. Again, I don't want decimals right now. Leave it as a fraction. Let's do one more. Let's make it harder. Yep. Sorry. All right, I want the y to be by itself, correct? Always y equals. Unless it tells you to solve for a different variable, we always isolate y. Maybe sometimes it'll say solve for r. Okay, so to begin this problem, before I can even start doing inverse operations, I need to simplify it, correct? So that 3 goes to the negative 2x and to the 3y. 3 times negative 2x is negative 6x. 3 times 3y is 9y, positive, right? So I put a plus, equals negative 18. All right, I'm going to highlight y again. I want y to be by itself. So if I pretend that x isn't there, if it's negative 6 plus 9y equals negative 18, which one do I move first? Negative 6x. I move that by adding. The opposite is positive, so I add it. My 6x's cancel out. I'm left over with 9y equals 6x minus 18. Perfect. I keep going because y is still not by itself. Divide by 9. Y equals. Can you do 6 divided by 9? It's a decimal, right? So I want to leave it as a fraction. But my question is, can you simplify 6 over 9 to 2/3 x? And what's negative 9 divided, or negative 8 divided by 9? Negative 18. Yep, you're right. Negative 18 divided by 9 is negative 2. So remember, When you're isolating the y variable, that's graphing part 1. In order to graph, it needs to be written y equals. So we do inverse operations to the constant, plus or minus. We do inverse operations to the coefficient, multiply or divide, and then we simplify the equation. Then you could take out that y, you could erase the y, and you could replace it with the function sign. And it would be a function.